Okay, so you have the equation x raised to the backward apostrophe a equals backward apostrophe b. In my case, backward apostrophe a stands for 5. And this is 4. Okay? Okay? So how do we solve this? What rule did I use to do that? What heuristic? It's actually heuristic, not a rule. Well, it's the very first one down below the laws of exponents. Okay? And you would want to document that. You want to say x of p equals c. You don't have to write out all the words. Okay? That's how you would document it. And you write that out. You can leave out some words, but write out the essential part of the thing so you reinforce what you're doing. Okay? Now, once you get it done, get it down and reinforced, once you know to do it, once you don't fail to do it anymore, then you don't really need to do that. But until you have totally reinforced it by doing several problems of this, by quoting it at least a dozen times, to get it into your head, you want to write that out. Okay? And then what do we do? X to the fifth to times 1/5. Okay? And you say, that's because x to the a raised to the b equals x to the a times b. You quote the law of exponents. Because that's how you learn the laws of exponents and think about what they mean. Okay, now this is, this is basic algebra. It's a prerequisite to this course, and we shouldn't have to be talking about it, but the fact is, this course is usually taught at such a low level that we have to. Okay. So that tells you that x to the 1 equals 4 to the 1/5. Okay, why is that? Because 5 times 1/5 equals 5 over 1 times 1 over 5 equals 5 over 5, which equals 1. Right? And I want you to write that out because people are bad with fractions. Now you might not be, so you might not have to do as many of these, but at least for this first set, I want to see that much detail in your solutions. Okay? And if you know it, it doesn't take long to write it out. You're only going to have to do maybe a dozen problems that way. And if you got it down, then okay. Okay? And then x equals 4 to the 1/5. You don't have to write cos. X to the 1 equals x. That's what it means for a sum to the power, right? Just 1x. As opposed to x to the square. Yeah, x to x squared, which would be 2x's. X times x, right? That's not 2x. When I say 2x's, I mean 2x's multiplied, right? Okay. And then you get your solution. And I don't know what, let's see, 4 to the 1/5 would be about 1.2 or 4, it's not that much. Yeah, it's not, I'd say about 1.3. But with your calculator, you get the exact number. Okay?
Right.
Okay, now you have your solution down below. Okay? I didn't write out a number because, of course, everybody has different numbers. Here's a simple calculation scheme. So I just give you the calculation scheme. I say, okay, D is going to be 1 over B, and X is going to be A raised to the D. Okay? What does that mean? Well, B is 4, so yeah, 1 over 4. Uh-oh. It's supposed to be X to the B equals A. Okay? So the calculation scheme that I gave applies to the problem on the sheet. Doesn't apply to this problem, so I got to fix it. So my A's have to become B's. Then I can follow the scheme and it'll work. Let's copy the problem down carelessly. Okay, so we're going to say D is 1 over A, and X is B raised to the D power. So D is going to become 1 over 5, because A is 5, and X is going to become B raised to the D, and that's going to be 4 raised to the 1/5, which is, of course, 4 to the 1/5, and that's what we got. Okay? So if you follow the calculation scheme, if the calculation scheme is correct, you should get the same number that you get here after you've done all the steps. Calculation scheme here just shortcuts the steps. And if you understand what you're doing well enough, you can see how that all comes right out of the calculation scheme. But you develop that idea, okay? So that's what we're going to get. Now, in the instructions before the problems, I say if your solution checks, and I left out a whole phrase there, it says if the solution checks, the given solution might be wrong. Well, what I meant to say is if the solution checks and the given solution doesn't check, then the given solution might be wrong. Okay? In that case, let me know about it. Right? Now, it could be that the given solution's right and you just messed it up. But the given solution, just step by step, you do this, you do this, you do this, and you should get the solution. Okay? Make sense?
Yeah, man.
Okay. Well, what you see here is 12 problems. They do the same way. Okay? Now they get more complicated, but we've already been over how you solve these. We've already got videos on them and everything. Okay? There's nothing here that we haven't seen how to solve. Nothing here that needs to use the properties of logarithms. But we'll do another example.
You want this whole packet done?
I'm sorry?
You want this whole packet done? Of course, you know.
Well, I'm telling you, I'll get to it.
Great.
I'll get to it. Okay? You got 12 problems there. Then I give you a different rule for your A, B, and C. Okay? And basically, D is going to become A, C is going to become B, and A is going to become C. You follow the rule. Okay? It isn't written that way. We've got to have a D in there so the rule works. But if you follow the rule, and y'all are good at following those rules, okay? I don't think you're going to have any problem with that. You're just rearranging your A, B, and C, and then you get to do them all again. Except I think I've got them in different order, so that you mix up the order a little bit. The first 12 problems, they're in progressive order, okay? So what you need to do some of the later problems is what you've already done in one of the earlier problems, okay?
Okay.
Then I mix them up, and that's the next 12.
What do you mean you mixed them up?
And then I give you different A, B, and C.
Oh, no.
Rearrange the A, B, and C again. A becomes C, B becomes A, C becomes B. Just a second, let me finish what I'm saying here, and then I'll answer both your questions. So we rearrange them, and I scramble the problems a little bit again. And by the time you get down to number 36, and all these are pretty short, except if you're writing out all the steps, it takes a little longer, but you need to do that, okay? And maybe in the later problems, you feel like you don't need to write out all the steps. At least write them out for the first 12, okay? But I recommend you write out all the steps for all of them until it becomes to seem to you so stupid to have to do that you don't have to. When it starts to really become and really feel stupid to have to write out all the steps, you probably don't need them anymore. Or at least you might not. Be sure you get to that state before you stop writing them out. And then if you want to, you can make up more A's, B's, and C's and go through them again. Okay? As much practice as you need. Okay, Clementine, you had a question.
When you rearrange the order of our A's, B's, and C's, or variables, does that apply to the one above it or the one next? The next
Well, no,
question?
when you get down, when you finish number 12, then you get to the reordering, so
Okay.
everything after that uses those A's, B's, and C's, right?
All right.
Now, the one thing that might be a little ambiguous is after you get number 24, you rearrange the A's, B's, and C's again. You use your original A's, B's, and C's, not the ones that you rearranged before. Okay?
So every time they're reordered, it's from the original,
Yeah,
your original value?
yeah. So that's a good question. Shane, you had a question.
Right, so when we get to here,
Oh,
Shane, did you have
that's what
a,
changes.
yeah,
yeah, do you have a question?
that you answered.
I thought maybe I had.
Here you
Okay.
change the.
Okay, good. Now there's some more stuff. Okay. So we do go down to the next group of 6 problems.
Oh.
Okay, that would be over on like the next to last page. I think there are 5 pages. That'll be the 4th page. After number 36.
Yeah.
Okay, everybody on it with me?
Find an
Okay.
approximate solution.
Then you've got
Whatever it is.
equations here that you're supposed to solve using the graph. Okay? Of the appropriate function. Like for the first problem, what function do you think? Okay, now, it has 2 to the x equals 2.5 plus your value of a divided by 10, right?
Mm-hmm.
So for me, my value of a is 5. That would give me 3. So my right-hand side would be 3, right?
Wait, what? How is 5 over 10 3?
5 over 10 is 1/2, and I add that to 2.5.
Okay, I got you now. Just
You're
making
missing the
sure.
2.5, but it's there. If you look at it, you're not going to miss that. Okay? Just look at it carefully and do what it says. All I'm saying is you got to do a little arithmetic to get the number that goes on the right-hand side, right?
Yeah.
And then what do?
Well,
Then
gotta
you take
make
the
it
graph of whatever the function is, okay? Now that's not going to be one of your basic functions. These all be basic functions.
No, it's, yeah.
And I say, okay, let's say my number is 3, that's my y value. I have this thing equal to 3, so I come over here and I find the x value, and that's my solution.
Right.
That's all there is to solving an equation using a graph. Okay? But that's only an approximate solution. You've got to be able to do the algebra. So what I ask you to do is do this with the graph, the thing that you know how to do, because everybody seems to be doing this pretty well. Okay? And compare that to what you get when you solve the equation by the properties, okay?
Yeah.
Because that reinforces what you're doing when you solve the equation, okay? And you know, all your you're gonna have to use your calculator for most of these. All your calculator is gonna do is they just got better graphs, and you get little guys in there that can, okay, well, that's not what they do, but,
So if the graph is too precise, you'll know.
yeah, well, you know, they have chips with
Won't be.
right architecture and all that stuff, and
that.
they have circuits, and they have algorithms, and they execute them, okay?
This
I think
bill-
mostly basic Taylor expansions, which is a simple thing,
Yeah.
if you know a year's worth of calculus, okay?
Well,
And not so simple if you don't, because it's kind of mysterious. It's just polynomials. They use polynomials, and that's what we're talking about right now in class. Okay? So we solve these equations and compare with the graphs, so you bring everything that you learn how to do with graphs into the context of what we're doing with algebra. Okay? And then I say repeat that and repeat that with rearranging your A's, B's, and C's.
From the original.
I'm sorry?
From the original.
Yeah, always from the original unless it says differently.
All right.
Okay? Make sense?
Right. Yes.
And then we have 19 more equations all mixed up. And I don't have to say any more about that because you've been assigned equations of that nature. Or they've been covered by doing those first 36 problems.
Well.
Okay. Okay, good.